When we take something in brackets, like a times b or a over b, and the whole thing's in brackets, and that whole thing is taken to the power of something, then that power applies to each of the things within the brackets. So let me show you. And you will need to make a correction to your booklets if yours look like mine. So if we have, for example, multiplying two or more numbers raised to the power of m. So we have number a times number b in brackets. You raise each number in the brackets, or per numeral, to m. For example, if we had 2x in brackets to the power of 2, it would be 2 to the power of 2 times x to the power of 2, because that's what's happening in there. So for this one up here, we have a to the power of m times, that should be, can I correct it? B, and that power should be the same power. So make sure you make that correction in your books. Similarly, if I've got a divided by b, all of that to the power of m, that means a to the power of m is divided by b to the power of m. And if you have numbers on the bottom, you might be able to evaluate some part of that. So y over 3 to the power of 3 means y to the power of 3 and 3 to the power of 3, which we can then turn into, we can evaluate to y to the power of 3 over 3 times 3 times 3 is 27. Now let's do some examples. So what we have here is expand each of the following using the index laws for brackets. So if we have 5 to the power, 5b, brackets to the power of 3, that means everything inside there goes to the power of 3. So 5 will go to the power of 3 times b to the power of 3. I can't do much more with to the power of 3, but I can do 5 to the power of 3, or 5 cubed. 5 times 5 is 25, times 5 is 125, and I keep my b to the power of 3. So that's how I have expanded that. If I have 2x, y, all of that to the power of 4, then I'm going to take 2 to the power of 4 times x to the power of 3 to the power of 4. So I'm going to multiply them times y to the power of 4. So 2 to the power of 4 is 2 times 2 is 4. So that is 16. That's my number 16. Times x to the power of 12, y to the power of 4. That's going to be my final answer. Now I've got a 4 on the outside of the bracket, so my 4 is not going to be raised to the power of 5. My 4 is going to remain a 4, and it's going to be multiplied by c to the power of 2 times 5, because that's all being taken to the power of 5, times d to the power of 3 times 5, because that's all being taken to the power of 5, which gives us 4c to the power of 10, d to the power of 15. That's our answer there. And finally, we have 3a squared on the outside. So this is going to be interesting. So I've got 3a squared times 2 to the power of 4 times a to the power of 3 times 4. So we still have our 3a squared times 2 to the power of 4, again, is 16, times a to the power of 12. Oh, that's very interesting. So I have 3 a's to the power of 2 times a to the power of 12. So essentially I have 3 times a to the power of 2 times 16 times a to the power of 12. So if I multiply 3 and 16, I get 48. And that'll be 48a to 12. We add those together because we're multiplying, so our end result is going to be a to the power of 14 for that one. Fascinating. Now we've got fractions. Apply the index law for fractions. Okay, so if I have 6 over b, 6 goes to the power of 3, and b goes to the power of 3 as well. And of course, I can evaluate 6 to the power of 3 to be 216 with my calculator, and I just have to leave b to the power of 3 as it is. Now, I've got a negative 2a squared. Oh boy. So everything here has to go to the power of 4 individually. So negative 2 has to go to the power of 4. We're going to keep it together as a negative, not that it would matter in this case, times a to the power of 2 times 4, right? Because we're raising to the power. And then on the bottom, we've got 3 to the power of 4 times b to the power of 4 times c to the power of 3 times 4. Are you actually kidding me? All right, keep going. Don't give up. So negative 2 times negative 2, positive times negative, negative times 2. So we end up with a positive 16 again. And a to the power of 2, 8 to the power of 2 times 4 is 8. And we divide that by 3 times 23 to the power of 4 is 81. And we stick with b to the power of 4, make that look more like a 1. And then c to the power of 12. And can we do any canceling in there? No. We can't. Amazing. Wow. And now, as if we hadn't had enough, all of this rigmarole goes x, let's just skip a few steps. X to the power of 2 times 3 is 6, times y to the power of 3 times 3 is 9, over c to the power of 3. So everybody gets moved to the power of 3, times x to the power of 4, times c to the power of 4, times y to the power of 4. Okay, so we're getting somewhere. Now we're going to start to combine some things, and if we multiply our way across, we get x to the power of 6 times x to the power of 4. I'm changing the order. Times c to the power of 4 times y to the power of 9, but I'm allowed to do that. Times c to the power of 3 times y to the power of 4, because multiplication is associative. I can change the order around. Now, x to the power of 6 plus 4 is 10. Times, I still got c to the power of 4 and y to the power of 9 over c to the power of 3 over y to the power of 4. So there's not much I can do with my friend x to the power of 10, but I can cancel out. 4 minus 3 gives me 1c on top, and 9 minus 4 gives us 5 on the top. Therefore, that's our final answer there. Or I can put it in any order, really. I can put it as x to the power of 10 times y to the power of 5 times c, or I could put it as c times x to the power of 10 and y to the power of 5, alphabetical. Either or is correct in the norm.